If a Tiger could destroy a Sherman first, why did the Sherman belong to the army that won? Because a tank war is not decided by one tank. It is decided by a system that can put crews, fuel, ammunition, repairs, replacements, and support in the right place, day after day. The Tiger was often the more dangerous machine in a duel. The Sherman belonged to the stronger deployable system. That distinction is not a trick. At Villers Bocage on June 13, 1944, a small force of German Tiger tanks struck the lead elements of a British column. The attack was a shock. Vehicles burned along the road, movement collapsed, and the Tiger's reputation gained one of its defining images. The reputation had a real technical foundation. The Tiger I's 88mm gun could kill most Shermans at ranges where the common 75mm Sherman struggled to answer through its frontal armor. The Tiger also protected its crew with armor that American tests treated as a serious problem. For the men inside a Sherman, an abstract lecture about logistics was no shield against the first shot. So begin by giving the duel its honest answer. If both crews saw each other on open ground, and if both vehicles were working, the Tiger usually held the advantage. But now change the unit of comparison. A battle-ready tank is not only steel and a gun. It is a trained crew. It is fuel delivered without interruption. It is the correct ammunition. It is a radio that connects the tank to infantry and artillery. It is a recovery vehicle when a track breaks. It is mechanics, spare parts, transporters, bridges, ships, ports, depots, and replacement crews. Remove enough links and the strongest tank becomes a bunker in the wrong place. That is why an inventory total and a readiness report tell different stories. A tank can exist on an army's books while waiting for an engine, a track, a radio, or a crew. Commanders fought with vehicles ready for action, not names on a ledger. The Sherman's advantage was not simply that replacements existed. It was that the organization had a better chance of connecting a replacement vehicle, a trained crew, and supplies before the next operation. The Sherman was designed inside that larger equation. The United States Army standardized it as a compromise among mobility, reliability, protection, and firepower. Strategic movement mattered from the beginning. American tanks had to cross an ocean, fit into ships, pass through ports, travel on railways, and cross the bridges available to an advancing army. Early limits held the design to roughly 30 tons and a width of about 103 inches. That compromise could be deadly when a Sherman met a Tiger. But it also meant that a Sherman could reach more of the places where the war actually had to be fought. Then came production. American factories built about 49,000 Shermans. Germany built fewer than 1,400 Tiger I tanks. Those numbers are famous, but quantity by itself explains too little. A tank parked outside a factory does not win anything. The important achievement was converting production into vehicles ready for action. At Detroit Arsenal, hulls moved through an industrial line fed by hundreds of suppliers. Standardization made parts interchangeable across a vast fleet. A gearbox, track component, or engine part did not have to be handmade for one individual tank. Maintenance units could stock known parts, train around familiar systems, and return damaged vehicles without inventing a solution each time. The next link was movement. Shermans went from factory to rail, from rail to port. Across the Atlantic into landing craft and onto the beaches of Europe. Every transfer consumed cranes, schedules, cargo space, and labor. A lighter, standardized vehicle did not make that chain easy. It made the chain repeatable. The archive shows that system at Cherbourg on November 4, 1944. Newly landed medium tanks were not simply driven toward Germany. United States Army Ordnance crews serviced them at the port, checked them, and prepared them for rail movement toward the front. The vehicle and its support process arrived together. None of this was effortless. Ports became congested, rail lines were cut, spare parts went missing, depots ran short, and crews became exhausted. Allied units still reported serious shortages. The comparative advantage was not a magical conveyor with no friction. It was an organization designed to find the broken link, route around it, and reconnect vehicles to the front again and again. The system continued after battle damage. On June 7th, a British Sherman crew in Normandy repaired suspension damage caused by an 88mm anti-tank shell. This photograph does not prove every Sherman was saved. Some burned beyond repair. Some crews were killed. But across an army, recovery teams, mobile workshops, spare parts depots, and salvage units turned a portion of losses back into fighting strength. That is the difference between tanks produced and tanks available tomorrow. The Tiger had a support system too. German mechanics were skilled, and many Tiger crews trusted their machines. The point is not that the Tiger always broke down. The point is that every Tiger demanded more from the chain. It weighed roughly 57 tons. Moving a disabled Tiger could require several heavy towing vehicles or another heavy tank, risking more equipment under fire. Rail transport revealed the burden in a particularly visible way. The Tiger's combat tracks made it too wide for the loading gauge. Crews removed the outer road wheels and side skirts, fitted narrower transport tracks, loaded the tank, and reversed the procedure after unloading. That work bought Germany a formidable gun and thick armor at the front. It also consumed time, specialist labor, rail capacity, and recovery power before the tank fired a shot. Now add the mission the tanks were actually performing. Most targets on a battlefield were not enemy tanks. They were anti-tank guns, infantry positions, buildings, roadblocks, trucks, and field fortifications. The Sherman's 75mm high-explosive shell remained useful against those targets. Its powered turret traverse, radio, and mechanical reliability helped the crew support infantry and respond to threats. And when heavier German armor appeared, the Sherman did not fight as a lonely gladiator. Allied formations could maneuver several tanks, call artillery, use infantry to find concealed guns, bring tank destroyers, attack supply routes, and force a withdrawal by advancing elsewhere. None of those tools guaranteed survival. Together they changed what victory meant. A Tiger could win a violent local encounter and still belong to an army losing the campaign. A Sherman could lose the direct comparison and still help an army move farther, recover faster, and return with more battle-ready vehicles. So the one-on-one question is wrong because it compares weapons while deleting the organizations that made them useful. The Tiger was often the stronger tank in the duel. The Sherman was the more sustainable part of a winning combined arms system, one the Allies could build, move, crew, supply, recover, repair, and keep fighting. The war was not won by the tank that looked strongest alone. It was won by the system that could still put a useful tank on the road tomorrow.